Hello everyone. In this video we're going to be solving a radical equation. Now this problem is from 100 problems in algebra, and this is one of the introductory problems. Anyway, so we have this equation x cubed minus 3x is equal to the square root of x plus 2, and we're going to solve for x values. So I'll be presenting kind of like two approaches. Even though the first method is not going to be very helpful, we'll still talk about it. So let's start with the first method, which will obviously be incomplete for a good reason. So when we have radical equations, a lot of times we want to get rid of the radical, don't we? So let's go ahead and square both sides. And that gives us x plus 2 on the right hand side, and the left hand side we have to square the difference. So that's going to be x to the 6th power minus 6x to the 4th power plus 9x squared. And that is equal to x plus 2. And then we're going to put everything on the same side. This almost looks like a bicubic. So we get this hexic equation, the 6th degree, which there's no formula for. There isn't a formula even for the quintic equations in general, and this is probably not a special one unless you can find a solution that works real quick. Obviously, you can try rational root theorem, but even if you found irrational solutions, you would have to divide by that, by factor theorem, and the resulting equation would be quintic. So solving the quintic would still be challenging. Okay, so this method obviously is not gonna give us anything solid unless there's a method that I'm not able to see at this point. Okay, but I just wanted to share with you, and at the end of this video I'm going to show you a really nice graph of two functions. Okay, great. So first method, square both sides, and not all methods have to, lead to the result. Sometimes you try a method and that doesn't work. That's perfectly fine. All right, let's go ahead and take a look at the second method. Obviously, the second method has to be something special, right? Since we start with the first method, it's kind of brute forcey, and then it doesn't lead anywhere except you get a hexic equation, which is probably impossible to solve by general methods. You can definitely use numerical methods, you can do approximations, so on and so forth, but solving this in general case is impossible. It's kind of sad, but that's the truth. So let's see how the second method works. I'm going to rewrite our equation. We have x cubed minus 3x is equal to the square root of x plus 2. Now, this second method is motivated by the presence of something under the radical. And also, the expression on the left-hand side should give you an idea too, right? So we're going to be doing a little bit of inequalities here. We'll talk about some trigonometry, so on and so forth. First of all, let's establish that the expression inside the radical must be greater than or equal to 0. So x plus 2 must be greater than or equal to 0 for this to have real solutions. And then this implies x is greater than or equal to negative 2. So this is a requirement, obviously. For any other values, we don't have any real solutions. So under those conditions, we can kind of split up this problem into two cases. Since we're going to use special substitution, it makes sense if we first assume our first case scenario. Let's call this first case. To assume that x is between negative 2 and positive 2. Now, why do we restrict the x to be on that interval? I'll tell you in a little bit. Now, whenever you have something like something is between negative 1 and positive 1, what do you think of? You think of sine and cosine of an angle, right? But when you have the negative 2 and the 2, you can still use that idea, but you just have to double the sine and the cosine. Make sense? So we're going to replace x with 2 times cosine theta, where theta is taken to be in the first and second quadrant. This is needed because we want half angle to be in the first quadrant. That's why I have this requirement. Make sense? So now if you go ahead and replace x with 2 cosine theta on both sides of this equation, you're going to get the following. 8 cosine cubed theta minus 6 cosine theta, that should tell you something, equals the square root of 2 cosine theta plus 2. Now, how does this help? Well, if you look at the left-hand side carefully and take out a 2, hopefully you recognize the triple angle for cosine. All right? And on the right-hand side, we can basically do the following. Replace the cosine theta with something that'll cancel out when multiplied by 2. So cosine theta, if you think about the half angle formulas, has 3 versions, right? The 2 cosine squared x minus 1, 1 minus 2 sine squared x, so on and so forth. And if I use 2 cosine squared theta over 2 minus 1, the negative 2 and the positive 2 are going to cancel out. So I'm going to replace cosine theta with 2 cosine squared theta over 2 minus 1. Make sense? And when I distribute to 2, I'm going to get a negative 2 and a positive 2. This is the double angle, or if you want to call that, what's it called? Half angle. That's fine too. Negative 2 and positive 2, like I said earlier, are going to cancel out. And this one is the formula for cosine 3 theta. So we have 2 cosine 3 theta equals this. And if you square root this, remember, we assume that our theta is going to be in the first and second quadrant. So half of theta would be in the first quadrant. Therefore, its sine and cosine are both positive. So this is going to come out as 2 cosine theta over 2 from absolute value. And since we have 2 2's, we can go ahead and cancel them out. They cancel out, and we end up with something like this. Cosine 3 theta is cosine theta over 2. This is a very basic trigonometric equation. We can go ahead and solve it real quick. And it's going to look like this. 3 theta is equal to theta over 2 plus 2n pi. It's going to be one of the solutions. If you put everything on the same side, you're going to get 5 theta over 2 is 2n pi. And from here, you get theta is 4n pi over 5. And obviously, for n equals 0, you get a 0. For n equals 1, you get 4 pi over 5. Make sense? And for the second piece, this is kind of like the A piece. And then the B piece is going to be with cosine. Remember, we always look at the opposite of the angle because first and fourth quadrants, remember, they have the same cosine. So if you put everything together, you're going to get 7 theta over 2 is equal to 2. Well, I could probably use a different integer here, 2k pi. And then if you isolate theta, you're going to get 4k pi over 7. And with k equals 0, you get 0 again. You don't need to duplicate it. And for k equals 1, you're going to get 4 pi over 7. But these are just the theta values, and x is equal to 2 cosine theta. So x values from here is going to be 0, 2 cosine 4 pi over 5, and 2 cosine 4 pi over 7. All right, so those are going to be the solutions of this equation. What about the other ones? Are they real, complex? Let's talk about it in the comment section. Now, let's go ahead and take a look at the graph real quick because these are really nice graphs of two functions. One of them is cubic. As you see, it has one maximum and a minimum, 3 real solutions. Obviously, you can find them. And then the other one is a radical, and they intersect at exactly 3 points. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care, and bye-bye.